I welcome you back to this wonderful tutorial. We are exploring bonding. Now there is a question which I was asked by one of is a question which I was asked by one of you. Question was on geometry. Now we're for electronic groups. And hope you still recall what an electronic group is. I assume that you still recall what an electronic group is. So I want to say that for 4 electronic groups, the geometry in general, the geometry is tetrahedral. In general, the geometry is tetrahedral. But the tetrahedral geometry, within the tetrahedral geometry, we have a trigonal pyramidal geometry. How is it formed? It is formed when you have 3 electronic groups and 1 lone pair. 3 electronic groups plus 1 electronic group, you have 4 electronic groups. You have 4 things, 4 that should be tetrahedral, but in particular, the shape becomes trigonal pyramidal. Another example is for water. Now look at the structure of water which we drew in class. The structure of water for covalent bonding. In that structure of water, this is what we have. You have O carrying H and another H. O carrying H and another H, like that. Then that O is having 2 groups, like that. So how many groups are these? 1 lone pair. Those are now 4 groups, 4 tetrahedral, but in particular, it is forced to become bent. It is forced to become bent or angular shape. This shape of water is bent or angular shape. Why? Can you take note of this? Take note of this diagram. I am assuming that you are noting them down. Now, previously for the valence shell electron pair repulsion, there was something which I explained. There was something that I explained there. You have, there was something which I highlighted. You have repulsion between pairs. They repel each other. The repulsion between electrons and a bond. You also have a repulsion between the bonds themselves. Now, once that repulsion occurs, it occurs in such a way that the resulting, within the resulting shape, we have the repulsion. That's why for the structure of water, the actual structure or shape of water according to the valence shell electron pair repulsion, that shape looks like this. It is a shape of this form. Why? Within the shape of this form, we have minimized the repulsion. That's why you see that these lone pairs are far away from this bond, and also these lone pairs are far away from that bond. Why? If they are close, once they are close, they will repel each other because the line is consisting of electrons. Also here within our lone pair we have electrons, so electrons repel each other so that the space is minimized. We reduce on that distance. The repulsion causes this thing here to increase so that after some time it is minimized. Yeah. So what have I said? For 4 electronic groups, we started with tetrahedral. Still for 4 electronic groups, we have seen trigonal pyramidal. Still for 4 electron groups, we have seen the bent shaped. Colleagues, it is important to know the type of geometry or the shape which can be formed in each case. We are going to look at examples. I want to repeat that for 4 electronic groups, you can have tetrahedral. For 4 electronic groups, you can have trigonal pyramidal. For 4 electronic groups, you can have bend-shaped. Recall that for tetrahedral, the example was methane for tetrahedral. For trigonal pyramidal, the example was ammonia. For bend-shaped or V-shaped or angular, the example has been H2O. But in all these examples, colleagues, I want to tell you that in all these examples, how many groups are we having? We are having 4 electronic groups. So this is still tetrahedral. This is still tetrahedral, but for methane, actual tetrahedral, ammonia, trigonal pyramidal, water, bend-shaped. Kindly take note of that structure so that we explore another electronic group. Take note of that information. It is there. So 5 electronic groups. Now for 5 electronic groups, 5 lines. Don't forget what an electronic group means. A single bond, a double bond, triple bond, or electrons. 5 electronic groups, 5 electronic groups, 5 electronic groups. You can have 5 lines. Like here, the one in phosphorus pentachloride, PCl5. PCl5. Those are 5. P is surrounded by 5 things, 5 groups like that. P is surrounded by 5 groups like that. So we call that trigonal bipyramidal. We call that trigonal bipyramidal. And what are the angles? Now this is a bit chaotic because we can have those that are situated in equatorial format at 120, and those that are at 90, and others at 180. A clear view is here. A clear view is there. Now, 4 groups. For 4 electronic groups. 4 electrons has resulted in formation of different 4 electronic groups. Now for 5 electronic groups, now this is the case. The first case is where we have 5 lines. 5 lines. The first case. The second case still for 5. The second case still for 5 electronic groups. One can have 4 groups and 1 lone pair. Those are 5. 4 groups and 1 lone pair. Like this one here. Sulfur tetrafluoride, and it is called the seesaw shape. You have 4 lines, 1 lone pair. There is also another case here. The T-shaped, it is here. You have 3. Hope it is noted here up. You have what? You have 3 electronic groups, 2 lone pairs. Those are still 5 things. They are still 5. You have 3 groups and 2 lone pairs, 5 things. They are still here. It is there. Then you can also have 2 electronic groups, 2 lines, and 3 lone pairs. 2 lines and 3 lone pairs. You see here, it is linear, but this linearity is under the case of 5 electronic groups. Don't confuse it with the linearity which we saw earlier on. This is the linearity under the geometry of trigonal bipyramidal. Yeah, so kindly take note of these cases. Let me recap this again so that you understand this better. So for 5 electronic groups, the geometry is trigonal bipyramidal. As I have highlighted, for 4 electronic groups, the geometry in general is tetrahedral. That is for 4. The geometry is tetrahedral, but within that tetrahedral geometry, you have tetrahedral shape, you have trigonal pyramidal shape, you have bent shape. Now for 5 electronic groups, I want to say the same thing. For 5 electronic groups, one can have 5 lines. I am assuming that you still recall what I mean by an electronic group. We can have 5 lines like these ones here, and we call that trigonal bipyramidal. Still for 5 things, colleagues, still for 5 things, I can have 4 lines and 1 lone pair. 4 lines and 1 lone pair, those are still 5. 4 electronic groups and 1 lone pair, those are still 5. For example, you have S that has a lone pair. It is surrounded by, this is what I mean, like that one. So this is still under 5 electronic groups. Still under 5 electronic groups, but it is not trigonal bipyramidal. It's not trigonal bipyramidal. The geometry is that. The geometry is trigonal bipyramidal, but the shape is not trigonal bipyramidal. Instead, the shape is seesaw. It's like within the trigonal bipyramidal, we have another geometry that is in 2D, the seesaw, like that. So another example is for 3 electronic groups. 3 electronic groups and 2 lone pairs. Those are 5 things. 3 electron groups and 2 lone pairs. Those are 5 things. So still this is called a geometry of trigonal bipyramidal. Because I have 5 things, a geometry of trigonal bipyramidal because of 5 things. But the shape is T-shaped. And finally, I can also have 2 electronic groups, of which there are also 3 that are lone pairs, 3 that are lone pairs, then total still is 5. So this is linear. And then the next case of exploration is for, allow me first stop this here.